When we explore the depths of space, we cannot help but marvel at structures that seem to defy the known laws of the universe. Our cosmological theories, developed over centuries, are constantly challenged by discoveries that seem too strange to be true. It's as if the universe is suggesting that our understanding of its fundamental laws may not only be incomplete, but perhaps even incorrect. In this context, the James Webb Space Telescope, JWST, which has been exploring the universe with its advanced infrared vision for 2 years, has offered new perspectives, revealing the farthest and oldest structures in the cosmos. The JWST has brought to light an extraordinary fact. The universe does not adhere to the models we have constructed so far. The telescope's discoveries have shown that while we try to make sense of the universe through theories and models, the true cosmic outgrowths seem to ignore our expectations. Every new revelation appears to throw established cosmological laws into disarray. A particularly puzzling example concerns the formation of galaxies in the early stages of the universe. Experts still cannot explain how, just a few 100 million years after the Big Bang, massive galaxies similar to our Milky Way could already exist. This discovery has led many to question the validity of current cosmological theories, suggesting that there may be mechanisms we have yet to understand. And this is just one of many questions raised by the JWST. The telescope has also highlighted unexpected phenomena in the planetary realm of the universe, showing that there are far more varieties of planetary systems than we imagined. Until now, we thought that planets, like those in our solar system, were always bound to a parent star, but the JWST has revealed the existence of planets traveling through the cosmos without a star to guide them. These solitary celestial bodies, known as rogue planets, were ejected from their original systems after formation, or in some cases, were never gravitationally bound to a star. An interesting case of these solitary planets is brown dwarfs, objects that form like stars, but lack sufficient mass to ignite nuclear fusion. These wandering planets are extremely difficult to detect, as they do not emit visible light and do not reflect starlight. However, thanks to the JWST's infrared observations, we can detect them through their heat emissions. Past research results have shown that rogue planets are not as rare as previously thought. In fact, astronomers have estimated that the Milky Way contains almost twice as many rogue planets as stars. For example, if our galaxy hosts between 100 and 300 billion stars, we can expect around 400 billion free planets wandering through space without a guiding star. One of the most interesting regions where these wandering planets have been observed is the Orion Nebula. This gigantic cloud of interstellar gas, located just 1,350 light-years from Earth, is one of the most active stellar nurseries in our galaxy. Astronomers estimate that about 2,800 young stars are forming within this nebula. In recent months, the James Webb Telescope has captured extraordinary images of the Orion Nebula, revealing a surprising new detail: more than 40 rogue planets, unbound to any parent star. While rogue planets had been discovered in the Orion Nebula in the past, this new discovery was particularly astonishing because the identified celestial bodies are enormous and have been named Jumbo Mass Binary Objects, JUMBO, a term that reflects their incredible mass. The discovery of the jumbos has caused great astonishment in the scientific community, especially since these solitary planets appear in pairs rather than as single bodies. Researchers have determined that the jumbos are relatively young celestial bodies, less than 1 million years old, with surface temperatures of around 1,000 degrees. But how were these giants born? One theory suggests that the jumbos may have formed in a region of the Orion Nebula too poor in material to form true stars. Thus, they might be akin to failed stars, formed through a process that did not lead to nuclear fusion. Another theory suggests that these objects might have formed as ordinary gas giants like Jupiter, but were later ejected from their original systems by unknown events. However, the real question remains, why do these planets always appear in pairs? Their configuration seems to suggest that there may be a particular mechanism in the Orion Nebula that leads to the formation of gas giant-like objects gravitationally bound to each other. If so, this would not be a coincidence but a fixed pattern that could exist in many other similar regions. The explanation for this phenomenon is still under investigation, but it could represent a new mode of planetary formation that we do not yet fully understand. Meanwhile, JWST observations are pushing the boundaries of cosmology ever further. One of the most extraordinary discoveries concerns the so-called impossible galaxies. These galaxies, which existed only 500–700 million years after the Big Bang, are enormous and already contain up to 100 billion solar masses of stars, a finding that challenges our theories of galaxy formation. According to current theories, there was not enough material to form such large galaxies in such a short time, leading scientists to wonder if our theories on galaxy formation are incorrect or incomplete. Another great mystery revealed by the JWST involves a massive supermassive black hole in a particularly young galaxy, just 770 million years after the Big Bang. This black hole has a mass exceeding 1 billion solar masses and is already fully mature. How did it grow so quickly? Experts have analyzed the feeding mechanisms that might have allowed this black hole to grow so rapidly, but found nothing unusual. On the contrary, the object's surroundings seemed surprisingly normal, leaving the mystery unsolved. Finally, the JWST has confirmed a mysterious Hubble tension, a discrepancy between theoretical values and actual measurements of the universe's expansion rate. While cosmological theories suggest the universe should expand at a speed of 67 kilometers per megaparsec, observations have measured much higher speeds, around 73 kilometers. This is not the result of a measurement error, but rather a discrepancy that might suggest the existence of cosmic forces or phenomena we have not yet considered in our models. Perhaps there is a form of dark energy or dark matter we know nothing about, or we may have misunderstood the laws of gravity. Whatever the cause, the Hubble tension is an enigma inviting us to revisit and expand our understanding of the universe. These discoveries from the JWST show us that the universe is far more mysterious and complex than we ever imagined. Each new revelation brings us to a greater awareness of our cosmic ignorance and pushes us to revise our fundamental theories because, as the telescope is demonstrating, the true nature of the universe is still entirely to be discovered. Thank you for watching. Leave a like, subscribe to the channel, and turn on notifications to avoid missing upcoming videos.